Hi guys, sorry I can't be with you today, but we're going to go over ions, which is 2.6 in this unit and the last thing that we do before the test. If you have any questions, feel free to send them to me on Remind, and I will help you out. Okay, so you have this video here on Blackboard, and then your homework is also loaded up on Blackboard. But let's get started. So 2.6, called the Bohr model, and happy atoms, called ions. All right, so let's see. Where's my pen here? Pen. This is 2.6. So, if you remember, here are some examples of Bohr models. All right, specifically, if we look up in this top corner, this is lithium, right? So, if you remember correctly, our rings go 2 in the first ring, 8 in the second ring, 8 in the third ring, 18 in the fourth ring, and 18 in the fifth ring. Right? So lithium having 3 protons and then having 3 electrons will do 2 in this first ring and then 1 in that second ring. So let's also look at sodium here. So let me zoom in. So here's sodium, right? If you get on your periodic table, you should see that sodium has 11 protons, which means right now sodium will have 11 electrons. Okay? Now, we're not going to worry about neutrons right now, so we're going to cross that out. So if we start drawing our model, in my first ring, I should put 2 valence electrons. 1, 2. There we go. In my second ring, I'm going to put 8. Okay, so here's my second one. So now I have 8 electrons. That's 10 electrons total, but I should have 11. So in my third ring, I'm going to put 1 more electron. Now, if you don't remember how to do Bohr models, that's okay. There are lots of videos on YouTube for you to go look at, and the notes are online. Okay? But YouTube is a great place to go for that. So here's my Bohr model. First ring has 2, second ring has 8, third ring only has 1. If you need a refresher on that, stop the video now and go do a refresher. Otherwise, let's move on. Here is our example of sodium again. Again, here's my 2 inner electrons. Here's my 8 in my second shell. And then here is 1 on the very outside. We would write this, because I have 11 protons, 12 neutrons, 23, 11 sodium. Remember, this is our mass number. And our mass number is protons plus neutrons. Protons plus neutrons. Okay? Bohr model diagrams. In our Bohr model diagrams, we're always looking at atoms as though they're neutral, which means their protons and their electrons are the same. An electron is arranged in energy levels or shells around the nucleus, right? 2, 8, 8, 18, 18. Electrons in the third energy level have more than electrons in the first energy level, or any electron in a higher level has more energy than an electron in a lower level. So the electrons in level 4 have more energy than electrons in level 2. The electrons in level 5 have more energy than the electrons in level 1, so on and so forth. The higher your energy level, the higher your ring. Right? The maximum number of electrons that can be in that first energy level is 2, and then the second and third is 8. Okay? These outer electrons, and I circled it here for you, those outer electrons are called valence electrons. Those are the electrons that are in the last shell, right? The ones on the very outside. So if we go back to sodium here, Sodium, how did I do this? Here we go. Sodium has 1 valence electron. Okay? There's my 1 valence electron. I have 2 in my inner ring. Oh, I'm doing a bad job here. 2 in my inner ring, 8 in my next ring, 1 in my outermost ring. That's 1 valence electron. Oh, let's see. Let's get that. Okay, steps to drawing Bohr models very quickly so that you can see them. Determine the number of protons and neutrons and electrons in each element. Present the nucleus as a small circle, right? Like we did here with sodium. Right? And then make larger circles arranging the electrons around the nucleus. Right, here's your example of oxygen. Okay, so I got my protons and my neutrons. I have my 2 inner electrons in my first shell. Notice here I have 6 valence electrons. All right, 6 valence electrons. So happy atoms. Happy atoms are most stable when they have a full shell of electrons, right? They really like 8. It's called the octet rule. We'll talk about that more later, but they like a full shell. So if I come back to sodium here, let's talk about sodium. Sodium does not have a full shell, so it's got a couple of options. It can either gain 7 electrons in order to get this shell up to 8, or it can lose 1 electron to then get the inner shell to now become my valence electrons. All right, I can get my inner shell to be stable. Now, some of you are going to be like, oh, gain 7, so then you're full. Full is good. Well, the question is it easier to run 1 mile to the right or 7 miles to the left? And you always go with the lower number. So my atom would rather lose 1 electron than to gain 7. Gaining 7 is harder. So if I look at sodium, I'm actually going to lose this outermost electron. And when I do that, I actually lose the whole shell. Good. So I lose that whole shell. Now I'm down an electron. So let me go back to my pen numbers. I don't have 11 electrons anymore. Now I only have 10. Because I lost an electron to make it happy. So now we need to represent our atom as having a charge. So if I have 11 protons, erase this. Right, I have 11 protons. Originally, I had 11 electrons. But now I'm down an electron, so there we go. All of these cancel out. These all cancel out with each other, right, because they're opposites, which means I'm left with 1 extra charge. That means that now my sodium is positive. So instead of writing just Na, I would write Na positive. Or I could write Na positive 1. Okay, both are considered correct. But I have to represent the fact here that I have 1 fewer electron than I did originally. Right? Because I want to make a happy atom. Everybody wants to have happy atoms. Okay? Let's look at another example. Okay, here I have oxygen. Oxygen has 8 protons and it's going to start with 8 electrons. Now, I notice that my second row can hold up to 8 electrons, but it's only holding 6. So, in order for it to be a happy atom, It either has to gain 2 electrons to fill this shell, or it has to lose 6 electrons to get to that inner shell. So what oxygen does is it gains 2 electrons. Let me get a different color. Alright, so I'm gaining 2 electrons to give myself that full shell, right? Because that gets me up to 8. That's good. So here are my original, this way, here are my original 8 protons and my original 8 electrons, but now I have 2 more electrons. All of these cancel out except for these last 2, which means that overall I have 2 extra negative charges. So I would write oxygen as O2 minus. As in, I have my oxygen, but it has 2 extra electrons. And since electrons are negatively charged, I have to represent them as 2 minus. Let's do one more example. Okay, so here's our last example, fluorine. Fluorine. Alright, so fluorine from the periodic table you should know has 9 protons and thus 9 electrons. Alright, so in my inner shell here, I have my first 2 electrons, then I have 7 in my second shell. But my second shell can hold up to 8. So in order to have a happy atom, I have to get it up to 8. So I'm going to add an extra electron. There you go. To get fluorine up to this way. Yep. To get fluorine up to being a happy atom. Which means this down here gives me an extra electron. Alright, so I've changed my pen numbers now. So these, again, all of these cancel out. Right, and I'm left with 1 single negative down here at the bottom. So I'm going to write fluorine as fluorine negative, or fluorine negative 1. Both is acceptable. Okay? In your homework. Okay, so this is your homework for tonight. So, on the first page, it's all about ions. Now, the second page is about isotopes, which would be good review for you. But this is the page that we're focusing on. Here it gives you an example. So notice we have the element fluorine. If you find fluorine on the periodic table, it has 9 protons. But this is giving you the symbol F negative, which is telling you that it has 1 extra electron, because electrons are negative. So the number I have of electrons is now 10, and I've gained 1 electron. So let's go to this next one. If I have 53 protons, my element is iodine. Right, so here I would write iodine. Notice I have 54 electrons, so I've gained 1, and it's negative. So here I would write I minus, just like in this example above. I've gained an electron, so now I have to add a minus up here. Okay, if I've gained 2 electrons, then up here I would write 2 minus, etc. That should be enough to get you through the homework. Again, if you have any questions, feel free to reach out to me on Remind, and I will try and answer them as best as I can. Feel free to work together, and know that you have a test next class. All right, bye guys.